When Lieutenant Colonel Peter Norman Nissen walked through the muddy building sites near EPI in early 1916, he wasn't thinking about making history. He was watching British soldiers suffer in the cold while they waited for good shelter. War on the Western Front had destroyed normal ways of building. There wasn't enough wood, most skilled carpenters were fighting in the trenches, and every new building had to survive enemy shell attacks. Nissen, a Canadian-born mining engineer serving with the Royal Engineers, had noticed piles of wavy metal sheets lying unused near supply depots. These sheets were meant for roofs, but now they were just sitting there while men froze in tents that collapsed under snow. The smart part of Nissen's idea wasn't that it was fancy. It was that it was very simple. He took those metal sheets and bent them into the shape of half a cylinder. This shape didn't need any beams or poles inside for support and could be built right on the ground. In March 1916, he built the first test hut at EPI with only regular army tools and 6 soldiers who had never built anything before. They finished it in less than 4 hours. When Nissen showed his design to British Army Command, he made one promise that changed everything. Any regular soldier could build the hut in 3 days, and all the parts could fit on one truck. The British Army tested the idea right away at Richborough Port, where soldiers from the 172nd Tunnelling Company put up 20 huts in April 1916. Each hut was 16 feet wide and used about 600 square feet of steel. The curved shape helped rain and flying metal slide off instead of breaking through. Since the huts had no straight walls, shells couldn't easily rip them apart. By June 1916, Nissen huts were being built all across the Western Front. The War Office gave its first giant order that August, 10,000 huts to be made and shipped before winter. What made the Nissen hut so special wasn't just how fast it could be built. It was that it didn't need experts. Before military, buildings required trained carpenters, stoneworkers, and engineers. Nissen's design needed none of that. The steel sheets already had holes drilled exactly 14 inches apart. The wooden walls came in ready-made panels. Builders didn't even have to make a foundation. They could bolt the hut straight to wooden beams or even hard dirt. A sergeant and 5 soldiers could unload the parts, set up the base, and have a weatherproof hut ready by nightfall. During the Battle of the Somme in late 1916, crews were putting up Nissen huts while still under enemy fire, giving fast shelter to wounded men from the front lines. The hut's size was carefully planned. Its 16-foot width allowed 2 rows of beds with a walkway in the middle. It could house 30 men comfortably, or 50 in emergencies. The curved roof, about 15 feet high in the center, gave enough room for people to stand. Air came through vents at each end, and tiny gaps in the metal sheets stopped the stuffy moisture that made tents wet inside. By the end of the war, in November 1918, British forces had set up over 100,000 Nissen huts across Europe, the Middle East, and Africa. They were used as sleeping quarters, hospitals, storage buildings, and command posts. Anywhere quick buildings were needed. The design plans Nissen sent to the War Office in April 1916 showed why his hut beat all the others. Normal military huts used upright frames, beams, and roof supports that had to be measured and cut exactly. Nissen skipped all that. His curved metal sheets held themselves up. The roof and walls were one piece. When you bolted one sheet to the next, you weren't just closing a gap. You were making the whole thing stronger. Each 16-foot section overlapped the last by 3 inches, and the bolts went through 3 layers of metal, spreading weight and pressure across the whole surface. The steps to build it were so simple that no one could really mess it up. Step 1. Lay wooden baseboards in a rectangle. Step 2. Bolt upright ribs to those boards every 7 feet. Step 3. Attach the first metal sheet to the ribs and bolt it to the base. Step 4. Add the next sheet overlap it, and bolt it again. Step 5. Keep doing this until the half circle was finished. Step 6. Finally, attach the wooden end walls, which already had doors and windows built in. A trained crew could build one hut in 72 hours. New troops could do it in 4 to 5 days. The British Army tested this many times during the summer of 1916 at training camps in Dover and Southampton. They timed how long different units took so they could plan construction schedules for war zones. What made the Nissen hut different from copies made later was how well it worked with the materials Britain already had. Nissen designed it to fit what factories could easily make during the war. The steel sheets were thin but strong, thick, enough not to break, light enough for 3 men to carry one without machines. The curve of the roof was measured so that factories could bend the metal using their normal tools without changing anything. The bolts were the same size as ones used in shipbuilding, so supply lines didn't need to stock special parts. The wood used for walls and base plates could be any kind available: pine, oak, or even salvaged boards from broken buildings. This made the hut easy to adapt anywhere. In Mesopotamia in 1917, British troops built Nissen huts without wood ends, using bricks from damaged villages instead. In Egypt, they placed the huts right on sand and used palm tree trunks for inner supports. No matter what they used, those curved metal sheets always made a weatherproof shell. In March 1917, a Canadian unit built a Nissen hut at Vimy Ridge while under bombardment. They worked in 30-minute shifts between explosions and finished in 18 hours. It became a shelter for 40 injured soldiers right away. The real speed advantage showed up in transport. One railway flat car could carry all the materials for 8 complete huts. 48 metal sheets, the wood pieces, and all the bolts. At a large military camp in France, building teams worked non-stop in 1917, finishing one hut every 6 hours when taking turns. By October 1917, the camp had grown to hold 100,000 troops, almost all living in Nissen huts. The hospital area alone had 300 huts with room for 12,000 patients. When Germany launched its big attack in March 1918 and 20,000 new wounded men needed shelter, soldiers built 70 hospital huts in just 11 days. The United States Navy sent its first engineering study team to Britain in September 1940, more than a year before the attack on Pearl Harbor. Commander George F. Doriot from the Bureau of Yards and Docks in Washington was told to look at how the British built their temporary buildings and see if those methods could help the American military grow faster. Doriot spent 6 weeks visiting air bases, army camps, and navy sites all over England and Scotland. His secret report, finished in November 1940, had 18 pages about the Nissen hut. He wrote down how fast the huts could be built, what materials they used, and spoke with officers who had been building them since 1916. His conclusion was simple. The Nissen hut was the quickest field building ever made, but he also said that the American forces would need to change it to fit their own needs. Those changes started right after the attack on Pearl Harbor on December 7, 1941. The Navy chose Quonset Point Naval Air Station in Rhode Island as the testing site because it had active building projects and train access for shipping. Commander John Barney Cyrus led the design team using both Doriot's notes and real Nissen blueprints that the British had shared. The first American version was ready in February 1942. It looked similar to the Nissen hut, but had major differences that would affect all future versions. The American engineers changed how the hut held itself up, while Nissen's design used the metal panels as both the walls and roof support. The new Quonset design added a steel frame inside. This frame had curved steel arches like ribs made from strong steel channels. These ribs stood on their own and carried the weight of the building. The wavy metal sheets on top were no longer part of the structure. They were now just covering attached to the ribs with screws. Cyrus believed this new method would make the hut stronger and able to hold heavy equipment and wiring. He was right, but it also made the huts harder and slower to build. The steel framework meant more pieces to move and more steps during construction. A normal 40-foot Quonset hut needed 14 curved steel ribs, each about 90 pounds, placed in exact spots and bolted to foundation plates. The walls could only be added once the frame was finished. In contrast, Nissen huts started with the metal sheets themselves, which created both the shape and the strength at the same time. This difference, building the frame first instead of the panels, added about 12 to 18 more hours of work based on tests at Quonset Point in March 1942. Navy leaders accepted the extra time because they wanted stronger, longer-lasting huts instead of the fastest ones. They expected most bases to stay for years, not weeks. The Quonset also added things the Nissen never had. Insulation became standard, using fiberglass blankets between the steel panels and inside wood walls. Electrical wiring was built into the frame instead of being added later. Wooden floors replaced the dirt or simple boards used in Nissen huts. Windows were larger and had screens. The doors used American-style hinges and locks. All of these changes made the huts more comfortable and practical. But they also made them heavier and more complicated to build. A full Quonset package weighed about 30% more than a Nissen hut. That meant it needed more trucks or train cars to move. By May 1942, the Navy had made 3 standard sizes for Quonset huts: 20 feet wide, 40 feet wide, and the largest at 50 feet wide. 2 big companies, George A. Fuller Company and Strand Steel Corporation, won the contracts to make them. Both had experience building prefabricated steel structures. The first mass-produced Quonsets were shipped to Navy bases in June 1942. The steel frame that made the Quonset strong also made it more dependent on factory-made parts. Each rib was shaped exactly for a certain hut size. If even one rib was bent or missing, the entire frame could fail. Nissen huts didn't have this problem. Their panels could bend slightly and adjust during construction. The Quonset ribs had to fit perfectly. Builders spent hours checking each rib with levels and measuring tapes to make sure they stood straight and evenly spaced. The number of bolts showed how much more complex the Quonset was. A 16-foot Nissen hut used about 200 bolts. A 40-foot Quonset needed over 700 bolts and screws. 14 steel ribs needed 84 bolts to attach to the base. Another 100 were needed to connect the ribs together. The metal panels required 16 screws each, and a 40-foot Quonset used around 30 panels. Then came the inside work: plywood lining, insulation fasteners, electrical boxes, and floor joists. Each step added more bolts, screws, and time. If tools broke or parts went missing, the work slowed down even more. American factories focused on making everything exactly the same. That made production smooth but caused problems in the field. Quonset parts were made under perfect conditions, but war zones were not perfect. When the 804th Engineer Aviation Battalion reached Henderson Field on Guadalcanal in January 1943, they found that humidity had caused some steel ribs to rust during the ocean trip. The damaged ribs couldn't be fixed locally because everything had to fit with precision. The soldiers had to wait 3 weeks for replacements while sleeping in tents. The insulation system also slowed down work. Crews had to install the fiberglass layer between the outer metal and inner plywood walls. This meant they had to build in 3 steps: set up the frame, add the outside panels, then go inside to add insulation and wood lining. Nissen huts were simpler. Once the panels were up, they were ready to use. Any extra comfort could be added later. At the Navy's Camp Endicott in Rhode Island in 1943, instructors timed both systems. A trained crew could build a Nissen-style hut in 48 hours. The same team needed 96 hours for a Quonset with full insulation and wiring, Adding electricity made things even slower. The Quonset's design had wiring paths inside the frame, so electricians had to work at the same time as builders. In safe bases with enough electricians, this worked fine. But in war zones with fewer people, electricians moving between sites caused delays. One Navy battalion in the Solomon Islands reported in April 1943 that wiring work delayed each Quonset by 2 extra days. The floor was another big difference. Nissen huts didn't have built-in floors. Soldiers just used wood planks or poured concrete afterward. Quonset huts had full wooden floors, which meant more carpentry work. When General Patton's army landed near Casablanca in November 1942, his engineers had orders to build camps for 35,000 soldiers using Quonset huts. But the sandy ground made things tough. The heavy steel bases twisted because the sand didn't hold bolts well. Crews had to spend extra days fixing the foundations and balancing the frames. It took about 4 days per hut instead of 2. At the same time, British troops nearby were putting up Nissen huts shipped from Alexandria. A group of Royal Engineers and local Algerian workers built 16 huts in 9 days. They didn't even use foundations. They placed the panels directly on sand, bolted them to wooden sleepers, and packed sand around the base to keep them steady. When strong winds hit later that month, several unfinished Quonsets fell over because their frames weren't yet covered. The Nissen huts, already complete with their curved metal shells, stayed standing. The Pacific region showed even bigger differences. On Guadalcanal, Marines began receiving Quonset huts in February 1943 after months of living in wet tents. Sergeant Robert Leckie wrote in his diary about how the metal frames got too hot to touch under the sun. Crews could only work in the early morning and late evening, so it took almost 2 weeks to finish huts that were expected to take 5 days. Meanwhile, Australian forces nearby used their own simpler Nissen-style huts made in Sydney. They built them using only metal, no wood, and could finish one in 36 hours on average. When Admiral Nimitz ordered the building of a new base at Funafuti Atoll in March 1943, the Navy needed homes for 5,000 men in 2 months. Builders had both Quonset and Nissen huts. The commander, Joseph Blondin, divided his men to test both under the same conditions. The results were clear. Nissen huts took about 54 hours to build from start to finish. Quonset huts took about 91 hours, mostly because of the framework and insulation steps. The speed difference became most important during emergencies. After the Battle of Midway in June 1942, the Navy urgently needed more hospital space at Pearl Harbor for wounded soldiers. The main hospital couldn't handle so many patients. If they used Quonset huts, which needed strong bases, frames, and full interiors, it would take 2 weeks. Instead, crews decided to mix designs. They built Nissen-style curved shells in just 3 days and added medical equipment later. These quick hospital buildings stayed in use through 1944 and helped treat more than 2,000 patients. Weather brought more surprises. Quonset huts stayed comfortable in both hot and cold places because of the insulation, but their double walls trapped moisture. In the foggy Aleutian Islands in 1943, water built up between the metal and the inner plywood, causing rust and mold. The simpler Nissen huts, with only one layer and small air gaps, stayed drier even though they were less warm. American factories soon turned the Quonset hut into something massive, a huge industrial success that small-scale Nissen builders could never match. By July 1943, the Strand Steel Corporation in Indiana was making 200 full Quonset hut kits every day. Another company, George A. Fuller, made 150 more daily in Pennsylvania. Together, they produced over 100,000 huts each year. This large production needed perfect standardization. Every part had to fit with any other hut, no matter when or where it was made. A rib built in January 1943 had to match a panel made in August 1944 American. Factories made this possible through precise machines that bent and punched steel into shape the same way every time. The British had never done it on this scale. Standardization went beyond shape and size. Quonset huts came in only 3 widths, 20, 40 and 50 feet, and the length could be increased in 10-foot sections. This made shipping easier. One train car carried one 40 by 20-foot hut kit. Supply depots could stock identical parts that fit any hut of the same width. This system removed the flexibility of the British design but made the building process predictable. When it came to cost, the difference showed what each country valued. In 1943, a full 40 by 20-foot Quonset hut cost about $850, including insulation, wiring and flooring. A similar Nissen hut, based on 1918 British prices adjusted for inflation, would cost about $230. The Quonset was 3 times more expensive. But the Navy believed the comfort and electric systems justified the price. Still, building thousands of them made the cost huge, over $140 million by the end of the war. Production numbers told another story. The US built about 170,000 Quonset huts between 1941 and 1946, around 34,000 per year. Britain made roughly 100,000 Nissen huts in only 3 years during World War I, about 50,000 per year, even with fewer factories. The difference wasn't in skill or machines, but in design. The Nissen hut only needed basic steel sheets, bolts, and wood. Any small factory could make its parts. The Quonset needed specially shaped steel ribs, exact holes, and coordination between many suppliers for insulation, electrical wiring, and wood. The trade-off showed clearly in how each type could be used. After a Quonset hut was built, it could be improved easily. Soldiers could add walls, install heaters, run more wires, and hang heavy tools from the frame. This made them great for long-term use, bases, schools, and offices. For example, in 1943, the Navy base at Alameda in California got over 400 Quonset huts. They became workshops, classrooms, and offices. Many were still standing when the base closed in 1997, over 50 years later. This proved that the American design worked best where permanence mattered more than speed. But in short-term war zones, the strong steel frames were a problem. When the 43rd Infantry Division moved from Guadalcanal to New Georgia in June 1943, they couldn't take their Quonset huts with them. The steel ribs were hard to unbolt and reuse. Nissen huts, on the other hand, came apart easily. The soldiers could take them down, move them, and rebuild them somewhere else. The British often moved entire camps. This way would be from Egypt to Italy to Greece, reusing the same huts as the war moved forward. After the war ended in 1945, the difference between the two designs became even clearer. The US military had around 70,000 extra Quonset huts left over on bases that were closing. The War Assets Administration, which handled old military supplies, started selling them to civilians in 1946. Prices ranged from $200 to $600, depending on size and condition. Farmers, small business owners, and families looking for cheap homes quickly bought over 15,000 huts that year. Because Quonset huts already had floors, insulation, and wiring, people could move in right away. They became homes, shops, and barns all across America. This began an American building trend that lasted for decades. Even today, if you drive through Iowa, Kansas, or Nebraska, you can still see Quonset huts used as grain storage or machine sheds. Small airports used them as airplane hangars through the 1970s. At the University of Illinois, returning soldiers and their families lived in a Quonset village. From 1946 until 1972, the 260 huts were supposed to be temporary, but they ended up housing families for over 25 years. These huts worked so well for civilians because of the same things that made them slow for soldiers. The insulation kept them warm or cool year-round. The strong frame held shelves and heavy tools. The inside could be finished with paint or drywall to look like a normal home. Britain took a very different path with its Nissen huts after the war. The army didn't want them anymore because they reminded people of hardship. Thousands were torn down, and the metal was sold as scrap during the post-war steel shortage. Some huts stayed on farms in Yorkshire and Scotland as barns or storage, but the government discouraged civilians from keeping them. By 1955, most Nissen huts in Britain were gone, except on remote training grounds or farmlands. The few still standing today are either protected as historical sites or hidden away on private land where owners use them for storage. The architects in both countries looked down on these huts. In the 1950s, American magazines called Quonset huts ugly and unfit for homes. The famous architect Frank Lloyd Wright even called them metal pig shelters. British architects were just as harsh. In 1948, one design journal said Nissen huts were corrugated embarrassments that should be removed as soon as possible. But these critics ignored an important truth. Both hut designs had saved millions of people by giving them quick, safe, and affordable shelter when nothing else was available. Other Commonwealth countries built their own versions after the war using the same idea. Australia made simpler huts for new immigrants and workers through the 1960s. They focused on speed and cost instead of comfort. Canada's military kept making Nissen-style huts for northern bases because Quonset huts with insulation caused ice buildup in cold weather. The single-layer metal design of the Nissen was safer and easier to heat. Over time, the military moved on from both designs. During the Vietnam War, new modular shelters were created that could be lifted by helicopters and built even faster. They used aluminum frames and fabric walls, making them very light. Modern armies now use expandable container shelters that can be set up in just a few hours, but they are far more expensive, around $50,000 each. Adjusted for inflation, that's about 6 times more per square foot than a 1943 Quonset hut, while offering the same basic purpose, shelter. The story of Nissen and Quonset huts teaches a big lesson. In war, faster isn't always worse, and better